back to our discussion about the limit of a function. So we know how to find the limit algebraically speaking, right? We know how to do that. Uh, in here, we evaluate limits algebraically speaking by what? Tabular form. You know, the table we made. Okay? Tabular form. But here's the question though. How about in graphing? Like what if I give you a graph? How will you evaluate the limits? So we're going to discuss that. Let me give you an example. Okay? So here, find f of 2. This graph is actually y is equal to x. Okay? So here, if in case you do not know the graph, you can basically observe it from here. Okay? First, you need to know your input. Then, you will find your y, which is your output, onto the what? Onto the graph. So, your input is 2. So, where's 2? Here. Now, let's find its y. So, it's from here, which is also 2. So, the answer is 2. That's it. Okay? So, again, if you don't know the graph, but you rely on the drawing, so base it from the input and, of course, uh, its y value. Okay? Now, how about this one? The limit of f of x as x approaches 2. So in the way how we solve limits before, which is right in tabular form, we use our left and right side, right? So let's try that. Let's have green, no wait, green as our left side. So we have this one, 0. Okay, start from 0. Or you know what, let's get closer here. As we get closer to 2, we have this one, right? So our y value is here. Okay. Now let's make it even closer. It's getting closer to 2. Now make it even closer to 2. It's getting closer to 2 as well. Okay. You get me? I'll show you. I'll show you. Hold on. It's like this, you know. It gets once your green, which is from the left, is here. So your y value is here. Now let's make it even closer to the x here 2. It's close. It gets closer to the 2 here. Let's make it even closer and closer and closer and closer. It gets closer to 2. So your left side is 2. Now how about on the right? So on the right, okay, we start from here, then gets closer and closer. So yes, they have their own y values, okay, but let's make it even closer and closer and closer and closer to the x value of 2. What happens? It's approaching to this value of 2. So therefore, your right is also 2. And since both sides are the same, therefore the answer here is 2 as well. You get me? So you see the difference. So here, if we have a function of 2, we just basically, plot. Like we have an input of 2, so we have 2 here. Now, find its y value. Just take a look. Just go up and there, it's here, which is 2. Now, how about this one? For this one, we need 2 points. Okay? 2 points getting closer to the x value of 2. So from here, we have your y value here, which is this one. If we get closer here, we have your y value of this, which is this one. And if we get closer to the x value of 2, we have this as a result, which is also getting closer to the y value of 2. You get me? And the same thing on the right side, we start from here, then gets closer to 2. So we have this one, and you have your y value, then gets even closer, and it's getting closer to 2. So they both approach to 2. So that's the difference between the two. So it's easy actually. It's actually easy that way. Okay? Let's try another example. we have this one. Okay. Find f of 1. Okay. What is the y value of f of 1? So here, this is 1, right? F of 1. Now, what would be our y value? In a graph, when you see a hole, this is actually a hole. Wait, hold on. This is actually a hole. So when you see a hole, what does it mean? It means it's undefined, or it's undefined or invalid. Okay? So if you see this hole, that means the answer would be undefined. So f of 1 is here, but the y value is here as well. Okay, it's here as well at this point. Okay, it's at 0. Okay, the y value is at 0, but you see it's a hole. So the answer here is undefined. Okay, but what if we have the same input and the same function, and let's get the limit out of it. Let's find the limit of this function as x approaches to 1. Okay, so we will do the same thing. Okay, let's start from the left. Let's just say 0.5 or midway to 0 and 1. Okay, so here your y value would be here. Okay, now let's get even closer to 1. So the y value would be here, right? Now it even gets closer to 1. So the y value is getting closer to 0. So if we let our points get closer and closer to 1, it approaches to what value? It approaches to 0, right? So that means your left is 0. Okay? Now, how about on the right? So, okay, we'll do the same thing on the right. So on the right, let's just say we start from here, which is 1.1. So your y value here is 1.1. 1.5 pala, sorry. This is this is the x value of 1.5. So if you're going to get the y value, it's 1.5. Let's get even closer to this one. So I'm assuming this is 1.25. So it gets closer to this y value, which is, I do believe it's 1.25, I guess. But what if we get even closer, closer to our x value? What is the result as we get closer to x value? It gets closer to 0, right? It gets closer to 0. So the right side approaches to 0. And since both of them are the same, therefore the answer is 0. Okay, the answer here is 0. So you see, guys, in getting the function and in an input, and then there's like an undefined answer like this, like there's a hole in it, they will not give you the answer actually. It's undefined. Of course, it's invalid. But with limits, it's not about exactly. It's about where it approaches. So from left, then going here, it approaches to 0. From right going there, it approaches to 0. Therefore, the answer is 0. Remember, limit is not about finding the exact. Okay? It's not about that. Rather, it's about approaching to. Okay? Approaching. Okay? It's approach. Getting closer to. Okay? So let's have another example. How about this one? Okay? What is f of 3? Oh, well, let's grab it out. F of 3, your input is 3. So 0, 1, 2, 3. So 3. Okay? Remember, if you see this, it means it's a whole. So it's undefined. Okay? But, you see, 3 may not be defined in here because, again, it's a whole. But you see this point, this one is shaded. When it's shaded, it means it's defined, meaning it's valid, it's defined. So you can have a y value here. But if it's a whole, no, that's not defined. It's undefined. But shaded, it's defined. It's okay. So 3 is undefined at this point. Okay, it's undefined at this point. But 3 is defined at this point. At this point, which is actually exactly 2. So the answer here is 2. But how about we do it the same way? Like, yeah, the same function, the input is 3, but we will find the limit. Okay? The same function, okay, like this, but we will find the limit, especially that we have the same inputs, just like this one. What would be the answer? Okay? So let's start from the left. So on the left, okay, since we're talking about as x approaches 3, so let's start with 2. 2 is from here, right? So it approaches, so it has 4. Let's make it even closer to 3. So it's actually here, which is the value is closer to 6. Okay. Now let's make it even closer to 3. Right? Closer to 3. Just like this, for example. So it's the value is approximately 8. Now let's make it even closer to 3, which is closer to the whole. So this is actually 9. This is actually 9. Right? It's 9. Okay? So that means from the left side, as x approaches to 3, what would be the result? 9. Okay? Okay? So x values as x approaches to 3, because here it gets closer to 3, so it approaches to 9. So on the left, it's 9. But how about on the right though? Okay, how about on the right? Let me erase this one. Okay, hold on. Wait. Just let me erase this one. Okay. It take a while, but yeah. Oh, whoa, whoa. Hold on. So let's start with 4. Okay, since it's about right going to the 3. So we start from 4. 4 is here. The y value of 4 is here, which is uh, I think it's approximately 3. Okay, but let's make it even closer to 3. I'm pertaining to the x value here. So here, the y value would be closer to 2. Now let's make it even closer to 3. So the y value gets even more closer to 2. And if we are here, which is approximately at 3, the y value is also approximately at 2. So as our x values gets closer and closer to 3, the result gets closer and closer to 2. So your right is 2. And as you can see, both of them are not the same. They are not the same. So therefore, the limit here is non-existent, or the limit does not exist, or DNE, because both of them are not the same. From the left, it approaches to exactly 9. On the right, it approaches to exactly 2. So no, the limit does not exist. Okay? By the way, if you see this one, like 3 raised to plus, that means the limit of function as x approaches 3 from the right side, which is from here going there. So the answer here is 2, right? And here, the same thing, but here we have the minus sign. That means the limit of a function as x approaches 3 from the left side. So meaning from left going to the 3. So the answer here is 9, right? And as you can see, they're not both the same. You know? This one, you see this plus and minus. This is actually the topic. It's actually involved in the topic of one-sided limits, in which we will tackle this one in the future. Okay, we will tackle this one in the future. So now at least you get the idea on how would you evaluate the limit in graphing or by graphing. Okay? So after this, guys, we will have a practice video so that you will try to master evaluating limits but by graphing. Okay? So see you soon.